So we're gonna go back to our scope, and you see here that we have channel 1 and channel 2 checkmarked. That means that as soon as I turn the scope on, which is you can press the play button or you can click run right here, it will turn on both of the signals. So you see that green line, that means that that's both of them on. You can turn off channel 2 just by check marking that off right there. So we want to see what our signal looks like. Right now we have a 10 kilohertz sine wave at a 2.5 volt amplitude. And so we're going to go back to our scope and check our channel and make sure that our channel is turned on. So we're going to play the Wavegen. We're going to turn on the Wavegen, and you see right here, you see that our graph is clipping a little bit. And that's because we need to adjust the voltage. So we're going to adjust the voltage range by going here to the channel settings, and we're going to change the range. So changing the range is going to make the sine output vertically smaller. So we're going to see that the graph shrinks according to how we change the range. And we can change it to specific range values. Say we wanted 1.5. That makes it even smaller. If you want it to be a little bit bigger, you can make the range value smaller. So say 0.5 volts per division, right? So this is this is still kind of like a little unclear. You can't really see the sinusoids being made out. So if you want to make it wider to see the individual sinusoids, then you can go to here, the base, the time base, and it'll make the graph wider for you. So say you want to zoom in more, you choose a smaller time base. So right now it's at 1 millisecond. Let's do 500 microseconds per division. And you should see that it gets a smaller. And let's make our time base even smaller right now. So you can go to 200 microseconds per division. And you see you get a little bit clarity on how that signal output is going. And so the wave generator is very good for just generating certain signals that mainly for a lot of labs, it's sinusoids. Sometimes if you're checking for a certain lab, it could be like a triangle wave or a certain wave that you're expecting out. The oscilloscope is very helpful in helping you to visualize what's going on in your circuit. Sometimes if I just even want to check what the voltage output is on my circuit, I will just check let's go see if we're going to generate just a plain DC signal. And the DC signal I set to offset to 0 volts, but we're going to offset it to, let's go to like 3 volts. That we would just want to output. The DC signal offset is just outputting 3 volts. And you see here that dotted line right there, it's because it's cut off because of the range is too small to be able to see the signal itself, because I put it at 3 volts. So we're going to change the range to 1 volt per division, and we can see it's right here at 3 volts. And if you just want to double check that, sometimes this feature becomes very helpful where you can read the individual measurements of each channel. So you can go to measurements, you can click add, and define the measurement. You can say for channel 1 or channel 2, but right now we're not using channel 2, so we're going to stick with channel 1. So you can check the vertical measurements, saying like the peak to peak, the average, the amplitude, and if you want like the amplitude, you click add. And usually sometimes you're expecting it to maybe X out, but that doesn't do that. This, you can click on as many measurements as you want to add and click add, and it'll still remain there until you X out of it. So let's do horizontal measurements, and we want to see what the frequency is, right? And you click add, and you can click close. So right here, it'll tell you the amplitude and the frequency. Right now, usually the frequency of a DC signal is not very necessary in some cases, but we're gonna let's go back to our sine wave and check the frequency of our sine wave and see. Let's change the offset back to 0 so we can get a better looking sine wave. And you can see that the frequency is at 10,000 kilohertz. You can see the amplitude is about 2.5 volts. And let's go back and check what our amplitude is, and that is around it is 2.5 volts. You can tell that the amplitude is kind of giving a little bit of error. That's okay. That's to be expected. Very few electrical systems are completely 100% perfect. There's always a little bit of error in the systems. So that's to be expected, but as long as it's 2.5 and around 10 around close to 10,000 kilohertz, that's fine usually. For a lot of labs and classes, sometimes they require you to be within plus minus 1% or plus minus 5% error, and that's completely okay. Like I said, no electrical system is completely without a little bit of error, you know. But this is it for this video. Thank you for listening, and bye-bye.